Hello guys, welcome to the new video. In today's video we are going to do the chapter 8 of class 9. We have done earlier the full summary. Today we will be doing the mid chapter questions. So we will start from page number 100. And first of all I want to tell you guys, do subscribe, like and share the video. Thank you. So let's start from the first question, which is an object has moved through a distance. Can it have zero displacement? If yes, support your answer with an example. So in this question it is asked that an object which is moved through a distance, can it have a zero displacement? So as we can see, yes, first of all the answer is yes, it can have zero displacement. How? An object has moved through a distance. Yes, the object, instead of moving through a distance, can have zero displacement if an object travels from a point A and reaches the same point A, then its displacement is zero, which means if an object travels a circumference, this is the distance, and comes to the same point which is A, its displacement becomes zero because its initial point and final point, both the points are on the same point. So this was to justify my answer whether yes or no. Thank you. So now moving on to the next question, in which it is asked that a farmer moves along the boundary of a square field of side 10 meter. Okay, let us take this as his field whose sides are 10 meter. Each and every side is of 10 meter. So now it is asked that the farmer moves along the boundary of a square field of sides 10 meter in 40 seconds. He completes the full round in 40 seconds. What will be the magnitude of displacement of the farmer at the end of 2 minutes 20 seconds from its initial position? Okay, now first of all we have to write some given points. The given points are the boundary of the square field is equal to 10 meter. Each side is of 10 meter. Now the time taken by farmer to complete one round is 40 seconds. Okay, now let us name this as A, B, C, D. Okay, now the farmer starts from point A, goes to point B, then to point C, then to point D, then to point D to A, which is the total time it takes is 40 seconds. And if we add all the sides, it becomes 40 meter. Now in 40 seconds the distance covered is 40 meter. Now let us take out the speed of the farmer. The speed will be, now speed is equal to V, which is velocity, equal to distance by time. What is the total distance? It is 40 meter and time is 40 seconds. So it is equal to 1 meter per second. Now it is asked about how much does the farmer what does the farmer do in which point does the farmer gets in 2 minutes 20 seconds. So in 2 minutes and 20 seconds, which becomes 2 into 60 minutes 60 seconds plus 20 seconds, which is a total of 140 seconds. Okay, now we have to take out the number of rounds the farmer completes, the number of rounds completed, which will be the total time, which is 2 minutes 20 seconds, and the time taken to complete one round by the farmer, which will be 140 by 40, which is equal to 3.5 rounds. So as we got in the last page, that the farmer will complete 3.5 rounds in 2 minutes 20 seconds. So which will be traveling from A to A, which is 40 seconds plus 40 seconds plus 40 seconds, which becomes 120 seconds. Now we have to go get up to 140 seconds. So to get up to 140 seconds, the farmer has to travel from A to C, which is more 20 seconds. Okay, so as to find displacement, this is the starting point for the farmer and this is the ending point for the farmer. So as we look in this triangle, this is a right angle triangle. So we have to put here the Pythagoras theorem. So now, as it is a right angle triangle, we have to put the Pythagoras theorem, because we have to find out the magnitude of the displacement, and the magnitude of the displacement will be found from the starting from to the ending point. Because as we can see here, suppose a man is traveling from here to here. This is the distance traveled by a man, and the shortest distance will be the straight line, and this is called the displacement. So now suppose this is A, as we can see here, and suppose this is B. Okay, this will be C. So we have to find the magnitude of the displacement, which is from A to C. So from Pythagoras theorem, which is hypotenuse square. What is the hypotenuse? Which is A to C. This is the hypotenuse square plus the adjacent side square, which is AD square, plus the opposite side square. This is the opposite side square, which is DC square. Now let us solve this. AC square is equal to, as we know, the sides are 10 meter. This is also 10 meter. So this will become 10 square plus 10 square. Again AC square is equal to 100 plus 100. Then again AC square is equal to 200. Then now AC is equal to root over 200. This square becomes the root this side. Now AC is equal to 10 root 2 meter. So now the answer is the displacement of the farmer at the end of 2 minutes 20 seconds is 10 to the power root 2 meter. So the next question is number 3. Here it is asked, which of the following is true for displacement? Number A, it cannot be 0. Number B, its magnitude is greater than the distance traveled by the object. So here both the options are not true. So the answer is none of the statement 1 or 2 are true for displacement, because it can be 0, which we have known in the first question. Distance is always greater than or equal to displacement, but displacement can be greater than distance. Okay, so now the next page questions, which is page number 102. Here the first question is asked that distinguish between speed and velocity. So there are many points between velocity and speed. Okay, so the first point will be, it refers to the displacement of a given object over a time interval, and here it refers to the distance moved by an object over a time interval. The second point will be, it has a specific direction. Number 2 here will be, it does not have any direction. The third point will be, velocity is equal to displacement by time, and here speed will be equal to distance upon time. Number 4, velocity can hold a negative value, and here speed cannot hold a negative value. Always remember guys, I don't write the questions of the answers I am giving. Always have the textbook in front of you, so read the question from there itself. I will be only doing the solutions of the questions. Okay, so the second question is, under what condition is the magnitude of average velocity of an object equal to its average speed? Okay, so here it is asked, and we have to give the condition in which the magnitude of average velocity of an object will be equal to its average speed. So now the magnitude of average velocity will be equal to average speed. Okay, then the magnitude of net displacement will be equal to the total distance covered. So the magnitude of the average velocity will be equal to average speed under a condition when net displacement, magnitude of net displacement will be equal to the total distance covered. This will only be possible when the object will do straight line motion, which is linear motion. Suppose a particle travels from point A to B. Let us say this is point A and this is point B. Okay, here the net displacement is equal to the total distance covered because both the distance and displacement are on the same line. This condition will only occur when linear motion is present. Okay, so we have been asked the condition. What will be the condition? So the answer will be under the condition of linear motion, the magnitude of average velocity of an object will be equal to its average speed. So the next question is asked, which is number 3. It is asked that what does the odometer of an automobile measure? So the answer will be the odometer measures the total distance traveled by the automobile. Okay, the odometer measures the total distance traveled by the automobile. Next, the question number 4. It is said that what does the path of an object look like when it is in uniform motion? So the path of an object in uniform motion is nothing but straight line. Okay, so now the 5th question is, during an experiment a signal from a spaceship reached the ground station in 5 minutes. Okay, what was the distance of the spaceship from the ground station? The signal travels at the speed of light, that is 3 into 10 to the power 8 meter per second. So what is given here? Here given is the signal travels in a straight line. Okay, then the distance between the spaceship and the ground station is equal to the total distance traveled by the signal. Okay, the total distance traveled by the signal is equal to the distance between the spaceship and the ground station. Okay, so it has given that the spaceship the signal from the spaceship reach from the ground station is 5 minutes. So let us take 5 minutes here. 5 minutes is equal to 5 into 60 seconds, which is equal to 300 seconds. Okay, so the signal speed is equal to 3 into 10 to the power 8 meter per second. So therefore, to find out the total distance, we have to multiply both. So 3 into 10 to the power 8 meter per second multiplied with 300 seconds, which we will get 9 into 10 to the power 10 meters. Okay, so the next questions are from page number 103. The first question is asked about, when will you say a body is in uniform motion and non-uniform motion? So for uniform, not motion, it's acceleration. So for uniform acceleration, in this type of acceleration, the body moves along a straight line and its velocity increases or decreases, okay, at a uniform rate. Okay, and the uniform rate, it changes at a constant rate in any constant time interval. It depends upon the time interval. Okay, so for non-uniform acceleration, so for non-uniform acceleration, in this type of acceleration, the body moves along a straight line and its velocity increases, otherwise decreases, at a rate that is not uniform. Okay, the uniform rate will change at the uniform rate will change at for a constant given time interval. It will vary in every given time interval. Okay, question number 2. A bus decreases its speed from 80 km per hour to 60 km per hour in 5 seconds. Find the acceleration of the bus. So given is the initial velocity, which is small u, is 80 kilometer per hour. Okay, so we have to change it in meter per second, so it will be 80,000, because it is kilometer, 80,000 divided by hour, which is 3600 seconds. Okay, so it will become 22.22 meter per second. So then the final velocity, which is small v, which is given 60 kilometer per hour. So 60 kilometer per hour, again we have to change it in meter per second. This is in meter, this is in second. So 60, 30 added, and 3600, which is meter, and this is second, which becomes 16.66 meter per second. Okay, now the time frame, which is t, is given just 5 seconds. Therefore acceleration A is equal to v minus u by t. Now what is v? 16.66 meter per second minus 22.22 meter per second divided by time, which is 5 seconds, which we get the answer as minus 1.112 meter per second square. Okay, now therefore the total acceleration of the bus is minus 1.112 meter per second square. It can be noted that the negative sign indicates that the velocity of the bus is decreasing. Okay, got it? Then next, the question number 3. Here it is asked, a train starting from a railway station and moving with uniform acceleration attains a speed 40 km per hour in 10 minutes. Find its acceleration. So given is the initial velocity, which is small u, of the train, that is 0 meter per second, which means it is at rest. Okay, then terminal velocity, or the final velocity, which is can be said the 10th minute. So it will be taken as terminal velocity, which is also can be said as the final velocity of the train, is 40 km per hour, which we have to find out. That is 40,000 by 3600 meter per second, which becomes 11.11 meter per second. So now the time interval, which is t, is 10 minutes. 10 minutes is equal to 600 seconds. Now the acceleration of the train is given by v minus u by t. Now what is v? V is 11.11 meter per second minus the initial velocity, which is 0 meter per second, divided by time, which is 600 seconds, which we get as answer, which is 0.0185 meter per second square. So the next questions are from page number 107. So the first question is asked about what is the nature of the distance time graph for uniform and non-uniform motion of an object. So for uniform motion, the distance time graph is a straight line. Okay, always remember that the distance time graph of a uniform motion, this is the distance, this is the time. The distance time graph of a uniform motion is always a straight line. Okay, it can be in this manner, it can be in this manner, but always remember the distance time graph of a uniform motion is always a straight line. Now next, for the non-uniform motion, the distance time graph for a non-uniform motion is a curve. Remember, the distance time graph of a non-uniform motion, this is the distance, this is the time, is always curved. It can be like this, it also can be like this, it also can be like this. So for uniform motion, the distance time graph is a straight line, and for non-uniform motion, the distance time graph is a curve. So the second question is asked about what can you say about the motion of an object whose distance time graph is a straight line parallel to the time axis. So the distance time graph can be plotted as like this, because since there is no change in the distance traveled, okay, since there is no change in the distance traveled, that is on the x-axis, at any point in the this is the y-axis. Since there is no change in the distance traveled in the y-axis, at any point in the x-axis, the object is at rest. This means there is no change in this distance traveled in x-axis, so there is also no change at any point of x-axis, because look at the distance, these two are parallel, okay, because the distance traveled is there is no change in the distance traveled, and at any point of x-axis there is no change. That is why the object is at rest. So now the third question is, what can you say about the motion of an object if its speed time graph is a straight line parallel to the time axis? Okay, the speed time graph can be plotted as like this, because since there is no change in the velocity, okay, there is no change in the velocity in the y-axis at any point of time. There is no change in the velocity in y-axis at any time. In different interval of times, the velocity is same. Okay, now it can be said that the object is at uniform motion. So the answer will be, since there is no change in the velocity of the object, there is no change in velocity of the object, that is at y-axis at any point of time in x-axis, so the object is said to be in uniform motion. Okay, got it? So now the question number 4. As I have drawn this diagram, it will be easier to understand. Okay, so the question is asked about what is the quantity which is measured by the area occupied below the velocity time graph. We have to measure the area occupied. This is the area occupied below the velocity time graph. This is the velocity time graph. Okay, so considering an object in uniform motion, let us consider this as uniform motion. Okay, so its velocity time graph can be represented as follows. This. Now we have to find out the area. So to find out the area, now the area below the velocity time graph is the area of the rectangle, which is OABC. This is OABC. Okay, which is given by length into breadth. Okay, which is OA multiplied by OC. But here OA is the velocity of the object. Okay, and OC, this is OC, represents time. Therefore it can be represented as area under velocity time graph is equal to velocity into time. So we have to find out the area, so we have to multiply velocity into time. Okay, now substituting the value of velocity as displacement. We are changing this velocity as displacement. Okay, displacement by time. We are changing this velocity as displacement by time in the previous equation, in this equation. Okay, in previous equation it is found that the area under the velocity time graph represents the total displacement of the object. Okay, first of all we have to change this velocity with displacement by time. We have changed this equation. From this equation it is found that the area under the velocity time graph represents the under this curve represents the total displacement of the object. This is the under this curve, this area represents the total displacement of the object. Okay, now the next question, which is from page number 109 to 110. Okay, so the first question is, a bus starting from rest moves with a uniform acceleration of 0.1 meter per second square for 2 minutes. Okay, a bus is starting from rest and moves with a uniform acceleration. So the initial velocity is 0 meter per second because it is at rest. Then the uniform acceleration is given, which is 0.1 meter per second, and the time is given, which is 2 minutes. So first of all we have to find the speed acquired. Okay, so the speed acquired, we have to find out the terminal velocity, which is also known as the final velocity. So first of all, A, which is as the speed acquired. So the given is the bus starts from rest. Okay, the bus is starting from rest and its initial velocity u is 0 meter per second. Okay, then given is acceleration, which is a, which is equal to 0.1 meter per second square. Now time is given, which is t is equal to 2 minutes, which is equal to 120 seconds. Now acceleration is given by the equation. The equation of acceleration is v is equal to a is equal to v minus u by t. So we have to find out v, which is the final velocity, or here which is terminal velocity. So therefore terminal velocity, which is v, we are bringing v to this side. Okay, so v minus u is equal to at. So we have to find out v. So now here v is equal to this will become at plus initial velocity. Okay, so we are now solving this. V is equal to at 0.1 meter per second square plus 120 acceleration, and this is time, which is 120 seconds, plus initial velocity, which is 0 meter per second. So here v will be this will become 120 plus 0.1, this will become 12 meter per second. This will multiply. Okay, 12 meter per second plus 0 meter per second. So velocity will become v will be equal to 12 meter per second. Okay, this is the terminal velocity, which is v, or the speed acquired. Now the second one is asked about that distance travel. So b, distance travel. So as per third equation of motion, here we have to use the third equation of motion. The three equations of motion are briefly described in the first video of this chapter. Okay, go through that. Third equation of motion. Since here acceleration is 0.1 meter per second square, then final velocity or terminal velocity is 12 meter per second, initial velocity is 0 meter per second, and time given is 120 seconds. So the following value for distance can be obtained as, so as we know distance, the formula of distance, which is s will be equal to v square minus u square by, which is divided by 2a. Okay, now what is v square? V square is 12 square minus u square. U square will be 0 square divided by 2a. 2a will be 2 into 0.1. So the answer we will get is, calculating this, will be 720 meter. So here this, for first one, the speed acquired is 12 meter per second, and the second answer will be the distance traveled will be 720 meters. So now question number 2, it is asked here, a train is traveling at a speed of 90 km per hour. Brakes are applied so as to produce a uniform acceleration of 0.1 meter per second square. How far the train will go before it is brought to rest? So we are given here the initial velocity and the uniform acceleration. So we have to find out how far will the train go before it is brought to rest. So it means we have to find out the distance. Okay, so first of all, given, always write the given. Okay, so it will be easy for you to solve any problem. So here is given the initial velocity, which is u, which is 90 km per hour. So we have to bring this in meter per second. Okay, so this will be 90 and kilometer comes to 30, and hour is equal to 3600 seconds, minutes. Okay, so this will come up here as 25 meter per second. Got it? Now terminal velocity. Terminal velocity v is 0. Okay, 0 meter per second, because the train is running. This is the terminal velocity, which will be 0. So now acceleration is given. Acceleration, which is a, is equal to minus 0.5 meter per second square. So as per third equation of motion, but this is the third equation, we have to use here the third equation of motion. Okay, the applying third equation of motion, v square minus u square divided by 2a. Okay, we have, sorry, this is not the third equation. Third equation is v square minus u square equal to 2as. Okay, so therefore to find out the distance traveled by the train, we have to find out s. S is equal to v square minus u square minus divided by 2a. Okay, so v square is 0 square minus 25 square divided by 2 into a, which is minus 0.5. Okay, so this will become 625 meters. Okay, so that here the conclusion will be the train must travel 625 meters at an acceleration of minus 0.5 meter per second square before it reaches the rest position. So now the third question is, a trolley while going down an inclined plane has an acceleration of 2 centimeter per second square. What will be its velocity 3 seconds after the start? So we have to find out the velocity after the start. So we have to write the given. Given is initial velocity, which is u equal to 0, because the trolley begins from the rest position. Okay, acceleration is 2 centimeter per second square. We have to bring it in meter. It will be 2 divided by 100 meter per second square, which is equal to 0.02 meter per second square. Now time is given, which is t, 3 seconds. So as per first equation of motion, v is equal to u plus at. So therefore terminal velocity of the trolley, which is v, we have to find out the terminal velocity. U is 0 plus at. Acceleration, this is a, which is 0.02 meter per second square, into time is 3 seconds. So this will be 0.06 meter per second square. Now therefore the velocity of the trolley after 3 seconds will be 6 centimeter per second square. We have again converted it to centimeter. Nothing, you have to multiply 0.06 into 100 and you will get the value in centimeters. Next is question number 4. In this question it is asked, a racing car has a uniform acceleration of 4 meter per second square. What distance will it cover in 10 seconds after the start? So here we have to find out the distance traveled by the car after it starts. Okay, in 10-second distance. So the given is the car is initially at rest. So the initial velocity, which is u, is equal to 0 meter per second. Then acceleration is given. Acceleration is a, which is 4 meter per second square. Then time period is given. Time period t is given, which is 10 seconds. Now as per the second motion equation, whose formula is S equal to ut plus half at square. Therefore, the total distance traveled or covered by the car will be S equal to u. U is 0 multiplied by t. T is 10. Then plus half. Acceleration is 4 multiplied by time, which is 10 square. Now this answer comes here is 200 meters. So therefore the car will cover a distance of 200 meter after 10 seconds. Now question number 5. It is asked that a stone is thrown in a vertically upward direction with a velocity of 5 meter per second. If the acceleration of the stone during its motion is 10 meter per second square in the downward direction, what will be the height attained by the stone and how much will be the time will it take to reach there? So here a stone is thrown vertically upward direction with a velocity of 5 meter per second. Then the acceleration of the stone during its motion is 10 meter per second square in downward direction. The acceleration in the downward direction is given, which is 10 meter per second square. Now what will be the height attained by the stone? How much time it will take to reach there? So we have to find out the height, means the distance traveled by the stone, and the time taken to reach there. So we'll start by the given information, which is initial velocity, which is u, is given 5 meter per second. Okay, then the terminal velocity, which is v equal to 0. Since the stone will reach a position of rest at the point of maximum height, this will become 0, because this will go up, then stop there, and again will go down. So that point is known as the terminal velocity, which will be 0 meter per second, because at that position, when it reaches the maximum height, it will be position of rest. Now again, acceleration, which is a, is given 10 meter per second square, and in the opposite direction of the trajectory of the stone. Okay, when it will come, it will go up, okay, direction to the trajectory of the stone will be in negative. Okay, now as per third equation of motion, p square minus u square is equal to 2as. So therefore the distance traveled by the stone is as equal to, what is v? V is 0. What is u? U is 5. 0 square minus 5 square equal to 2as. What is a? A is 10. Okay, sorry, s is here. We have to find the s here. So the distance s is 1.25 meters. So now we have found the distance. Now we have to find the time. So we have to write here as per first equation of motion, v is equal to u plus at. V is equal to u plus at. So therefore time taken is equal to time taken to reach the stone at a position of rest, which is the maximum position, will be v minus u by a. Okay, so v is 0 minus 5, u is 5 divided by a is 10. Okay, a is 10. Now we are finding the time taken to reach up that position. This will be the negative one. Okay, now the time taken is 0.5 seconds. Therefore the stone reaches the maximum height of 1.25. This is the maximum height, which is 1.25, and in a time frame of 0.5 seconds. So guys, here I end up the video. This is all the mid-chapter questions you need, and do practice, guys. These practice sessions will make you find easier this question solutions. As we know, practice makes us perfect. So thank you guys for watching the video. The third part is coming soon, which will be all about the exercise questions of the chapter 8 motion. So do like, share and subscribe.